How can a sugar pill relieve pain or improve symptoms, even when patients know it is not real medicine? This is the mystery of the placebo effect, where belief alone appears to trigger genuine physical changes in the body. Far from being just a psychological trick, the placebo effect has measurable biological impacts. It can release endorphins, modulate immune responses, reduce inflammation, and even alter brain activity. But how does this happen? The brain, it turns out, is a powerful chemist. When a person expects healing, the brain can activate internal systems like dopamine and opioid pathways that mimic the effects of actual drugs. In some clinical trials, patients given inert pills have shown improvements comparable to those on active medication, particularly in conditions like chronic pain, depression, Parkinson's disease, and irritable bowel syndrome. Does this mean illness is all in the mind? Not quite. The placebo effect does not cure cancer or mend broken bones, but it reveals that perception and expectation can strongly influence how we experience illness and recovery. Remarkably, even open-label placebos, where people are told they are taking a placebo, can still work as long as they believe in the treatment process. This suggests that belief, context, trust in doctors, and the rituals of medicine all play a role in healing. So what does this teach us? The mind and body are deeply connected. Harnessing the placebo effect ethically and scientifically may help amplify real treatments, improve outcomes, and deepen our understanding of human biology, not just as a machine, but as a belief-driven system with surprising self-regulating powers.
Can the mind alone trigger real healing, even when there is no active medicine involved? It sounds unlikely, almost magical, and yet, over decades of clinical trials, scientists have repeatedly observed a curious and consistent phenomenon. When people believe they're receiving treatment, their bodies often respond positively, even if that treatment is a sugar pill or a fake procedure. This is the mystery of the placebo effect. In the world of medicine, where effectiveness is measured by chemical interactions and physiological responses, the placebo effect stands out as something different. Patients given inert substances have shown improvements in conditions like chronic pain, depression, Parkinson's disease, high blood pressure, and even irritable bowel syndrome. But how can belief alone, without any pharmacological action, bring about such changes? The answer seems to lie in the brain's own pharmacy. When a person expects relief or healing, their brain responds by releasing neurotransmitters like endorphins and dopamine, chemicals that can reduce pain, elevate mood, and regulate other bodily systems. It is as if the body, convinced that help is on the way, starts to heal itself using its internal mechanisms. Consider a study where people with migraines were given placebo pills labeled as migraine medication. Many experienced relief. In brain scans, researchers observed activity in the regions responsible for pain modulation, just as they would with real medication. Or take the case of Parkinson's patients, who, after receiving a placebo, showed measurable improvements in motor control, linked to a spike in dopamine levels, as if they had received actual drug therapy. And it's not just about pills. Placebo surgeries, where patients are anesthetized and cut, but nothing is actually repaired, have led to recovery rates similar to those of real procedures. In some trials, people with knee pain improved just from the belief that their knee had been fixed. But is it all in their heads? Not entirely. While some placebo responses affect subjective feelings like pain or mood, others produce measurable physical changes in the body, alterations in hormone levels, immune responses, or neural activity. That's what makes the placebo effect so scientifically compelling. Belief alone seems capable of triggering genuine biological shifts. Then why don't doctors use placebos more often? The challenge lies in ethics. Traditional placebo use usually involves deception, telling patients they're receiving treatment when they're not. But interestingly, recent studies show that even when patients are told they're taking a placebo, they can still experience benefits. This suggests that the act of caring, the medical ritual, and the context in which treatment is given all contribute to the healing process. Of course, the placebo effect has its limits. It is most powerful in conditions where symptoms are subjective and influenced by perception, like pain, fatigue, anxiety, or depression. It is less effective for diseases that involve irreversible tissue damage or infections that require direct medical intervention. And not everyone responds to placebos in the same way. Some people are highly placebo sensitive, while others show little response at all. There is also a darker mirror to the placebo effect, the nocebo effect. When people believe a harmless substance will cause harm, they may actually experience side effects or worsening symptoms simply due to expectation. This reinforces how deeply our minds are tied to our physical health, for better or worse. So what does the placebo effect ultimately reveal? That healing is not just about chemicals and surgeries, it's also about trust, expectation, meaning, and the brain's powerful role in regulating the body. The placebo effect doesn't mean it was just in your head. It means that the mind has a real, measurable influence on the body, and in a world increasingly focused on high-tech solutions, it reminds us that sometimes the most profound medicine begins with belief. The placebo effect paradox refers to the phenomenon where people experience genuine physiological and psychological improvements after receiving an inert or non-inactive treatment, such as a sugar pill or saline injection. These improvements can occur even when the treatment has no pharmacological activity. The paradox challenges the materialist view that healing must arise solely from biochemical interactions, suggesting that belief, expectation, and meaning, intangible constructs, can influence real biological systems in measurable ways. In clinical trials, patients with chronic pain, depression, or even Parkinson's disease have shown significant improvement after taking placebo pills, sometimes rivaling the effects of the actual drug. It is like watching a locked door open just because someone believed hard enough that the key in their hand would work, even though it was just a replica. The placebo response is the physiological reaction triggered by the expectation of benefit, often occurring when a patient believes that they are receiving an effective treatment. This belief activates various neural pathways, particularly in the brain's reward, pain, and emotional centers, resulting in the release of natural substances such as endorphins, dopamine, and serotonin. These compounds modulate symptoms such as pain, mood, and inflammation. The response is not simply imaginary. It involves measurable biological activity across multiple systems. Functional MRI studies show that patients who believe they are receiving a pain-relieving drug activate the same brain regions as those who actually received morphine. It is like telling your brain a convincing lie. And your brain, instead of doubting, mobilizes its entire system to make it true. The placebo effect operates through several overlapping mechanisms. Expectation, believing in treatment triggers neural circuits associated with reward and healing. Conditioning, past experiences of care can condition the body to respond to familiar rituals or symbols, pills or white coats. And contextual cues. The clinical setting, doctor-patient interaction, and the ritual of treatment can reinforce the brain's perception of safety and healing. These mechanisms act through the central nervous system, modulating the autonomic nervous system, immune response, and hormonal regulation. In a study on Parkinson's patients, belief in a therapeutic intervention led to the release of dopamine in the brain, improving motor function despite the absence of an active drug. It is like a car that starts moving not because the engine turned on, but because the driver believed the ignition key would work, and somehow the wheels begin to turn. The placebo effect exemplifies how complex adaptive systems like the human body respond to informational signals, not just molecular ones. Healing becomes a function of self-organization within the system, where cognitive and emotional inputs reconfigure biological pathways. This suggests that the human body is not merely reactive to chemical agents, but is capable of top-down modulation, where the mind can shape molecular outcome. In sham surgeries where no actual procedure is performed, patients still report pain relief and functional improvements, often indistinguishable from real surgical outcomes. It is like rebooting a computer and fixing a glitch, not by changing the hardware, but by sending the right reset signal at the right time. The placebo effect can be seen as a reconfiguration of the body's internal energy flows, reducing the physiological costs of stress, anxiety, or inflammation. Belief in healing can shift the autonomic nervous system from sympathetic fight or flight dominance to parasympathetic rest and repair activity, allowing for better regulation of immune function, digestion, sleep, and tissue repair, producing real physical benefits even without external medical intervention. Patients taking placebos for irritable bowel syndrome showed improved gut motility and reduced discomfort, effects associated with enhanced parasympathetic activation. It is like dimming the noise in a room so that soft music becomes audible again. Belief creates the silence needed for healing to be heard. From an information theoretic view, the placebo effect demonstrates that meaning itself can act as a form of biological control. The brain interprets symbolic cues like pills, gestures, or words as signs of safety or danger and reprograms internal states accordingly. The placebo effect reduces uncertainty, reshapes predictive models in the brain, and realigns the body's behavior toward expected outcomes. Open-label placebo studies, where patients are told they are taking a placebo, still show significant effects, highlighting that awareness does not nullify belief's power. It is like reading a book that moves you to tears, even though you know it is fiction. The story still triggers a real response in your body and brain. The placebo effect reveals that healing is not just a chemical process, it is a psychosocial and informational event. This has deep implications for clinical care, therapeutic design, and the integration of empathy, ritual, and communication into treatment. Integrative clinics that combine conventional medicine with meditation, acupuncture, or ritual care often report higher patient satisfaction and better outcomes, not only due to the procedures, but due to how meaning is constructed around healing. It is like decorating the room before inviting guests. The environment shapes the quality of interaction, even if the meal is the same. Despite its potential, the placebo effect poses challenges in ethical medical practice and scientific research. Using belief as a treatment risks deception, which undermines trust, and it is also difficult to predict who will respond to a placebo and under what conditions. In placebo-controlled trials, sometimes the placebo group improves as much as the treatment group, making it difficult to distinguish actual drug effects from the influence of belief. It is like testing two parachutes, but both participants believe they will float. Sometimes belief alone changes the outcome, and the data becomes cloudy. Future research into the placebo effect is moving toward precision placebo science, where individual psychological, genetic, and neurobiological factors are used to predict and enhance placebo responses. Technologies such as virtual reality therapy, AI-assisted interaction, and wearable devices may be used to deliver tailored expectations and track psychophysiological changes in real time. This expands the role of the healer from drug dispenser to meaning architect, and of the patient from passive recipient to co-creator of health. Virtual reality experiences that simulate healing environments, such as peaceful forests or supportive clinical settings, can reduce pain and anxiety more effectively than medication alone, even when users know it is a simulation. It is like stepping into a dream that tells your body you are safe, you are healing, and the body believes it enough to start the work.